On a cool autumn afternoon, Ethan and Jenny walked into the old forest behind their school, carrying notebooks, ropes, and a small measuring tape. Their science teacher had given them a fascinating challenge. If a giant spider existed, how could it build a web strong enough not to collapse? Curious and excited, the two friends decided to search for answers in nature itself. As sunlight filtered through the tall pine trees, they noticed tiny spider webs sparkling with morning dew between branches. Ethan carefully observed how even small webs used many connecting points to spread weight
Notice how the
evenly.
weight is spread
Jenny
perfectly
sketched the
even
web
across
patterns
this
in
whole
her
network.
notebook, realizing that a giant spider would probably need hundreds of thick anchor lines attached to rocks, cliffs, and giant trees to support its enormous web. Deeper in the forest, the friends discovered a fallen tree stretching across a stream. Looking at how the tree balanced its own weight with support from both riverbanks gave Ethan an idea. A giant spider might build its web like a suspension bridge, he said excitedly. Jenny tied ropes between several tree trunks to test the theory. They noticed that when the ropes were pulled tightly from multiple directions, the structure became much stronger and less likely to sag. The experiment helped them understand that a gigantic web would need extra thick silk strands arranged in layers, with many support connections spreading tension across the entire structure. As evening approached, strong winds began moving through the forest canopy. Ethan and Jenny watched smaller spider webs bend and sway instead of breaking. This gave them another clue. A giant spider's silk would likely need to be flexible rather than completely rigid. Flexible strands could absorb wind energy and movement without snapping. Jenny imagined enormous glowing webs stretched between canyon walls or giant jungle trees, moving gently in the wind like giant nets. The pair wrote down that the silk would probably contain special elastic proteins, far stronger than steel by weight, allowing the web to survive storms and the spider's own massive size. Before returning home, Ethan and Jenny climbed a nearby hill overlooking the forest. From the top, they pictured how a gigantic spider might first release long silk threads into the wind to create the main support cables. Then it could carefully weave circular layers outward from the center, while constantly reinforcing weak points. The young explorers finally concluded that a giant spider's web could only survive if it used extremely strong elastic silk. Many giant anchor points, layered construction, and balanced tension across the entire structure. As the sunset painted the sky orange and gold, Ethan smiled and said, "Nature already gave us the clues. We just had to look closely."